Welcome to my channel. My name is Lauren and I am self-converting my Ram ProMaster to live, travel, and work in full-time on the road.
In today's video, I show you how I installed my 12 volt DC and 120 volt AC pre-wiring for my appliances, lights, outlets, switches, and more. As usual, check the timeline of this video for time codes that will allow you to jump around to different sections, and check the description box for affiliate links to products and tools I use. Also, go ahead and hit the subscribe button down below so you don't miss my next video of an in-depth install of my batteries, inverter, distribution panel, solar panels, and more. With that, let's get started. If you're just starting out with your electrical, I know it can feel very overwhelming. Trust me, I spent months researching this topic to make sure I was installing a safe and effective system, but I assure you, with enough patience and research, you too can do your own van's electrical install. To help, I'm going to walk you through the thought process start to finish before showing my actual pre-wiring install along with tips. And just for clarification, the wires I'm referencing here are the ones that are going to be carrying current from your distribution panel to your appliance, to your outlets, to your lights, and to your switches. To start, you'll want to make a list of everything you plan to power in your van. Things like a fridge, a blender, a hair straightener, phone chargers, and so forth. Once you have your list of items, you need to separate the list into two separate categories based on whether the unit is powered by 12 volt DC or 120 volt AC. So that begs the question, what is DC and what is AC? DC stands for direct current, meaning the current only flows through the wire in one direction. Whereas AC stands for alternating current, and the current changes direction periodically. The main difference is that 12 volt direct current can go straight to your 12 volt appliances, but the 120 volt alternating current needs an inverter to change the 12 volt DC into 120 volt AC. Because of this, you want to run as many things as you can off of 12 volt DC, assuming you're using 12 volt batteries, because it will be more efficient for this application. If you were to use 120 volt AC appliances, a lot of energy is wasted when converting DC to AC with an inverter. Ideally, the only thing that should be 120 volt AC in your van will be your outlets. So how do you know if your item is AC or DC? AC connections are usually for items that plug into an outlet. DC connections means the positive and negative wire from the distribution panel is wired directly to the positive and negative on the appliance. At the time of purchase and in the product's owner's manual, it should specify if the unit is AC or DC. For reference, here is a list of everything I will be running in my van for AC and DC. Now that you know what you plan on powering off of your electrical system and have separated the list into AC and DC categories, it's time to choose your wire. So the DC wires have two wires, a positive, which is usually red, and a negative that is usually black. However, the AC wires will have three wires, a neutral that is white, a hot wire that is black, and a ground wire that is green. Now the colors of wires can vary, so just be aware of what you're working with before you make any connections. For van builds, I commonly see the recommendation to use stranded wire as opposed to the alternative, which is solid wire. As the name suggests, stranded wire is made up of multiple tiny wires, whereas solid wire is one strip of wire. Stranded wire is more flexible, which makes it easier for this application moving through the curves of the van. Some people even claim that stranded wire can withstand vibrations of a moving vehicle better than a solid wire would. You also want to make sure the wire is tinned copper. This helps to prevent any corrosion and oxidation, and the wire needs a temperature rating of 105 degrees Celsius, which is about 221 degrees Fahrenheit. This is important because as current is moving through your wires, that can add heat to the wire, especially if the wires are next to other wires that are in use, if they're in conduit, behind your walls, next to the insulation on a hot day in the desert. all of those factors are going to affect the heat of your wires. So it's important that it can withstand those temperatures so that they can still properly work. I purchased marine grade wire. As the name suggests, it is wire that is commonly used in boats, and it can withstand the marine environments like water, strong winds, and corrosion. This is because of its protective covering around the wires, which also adds protection when running through your metal van with sharp edges. When using marine grade wire, refer to the ABYC standards, which is the American Boat and Yacht Council. One other call out is you can buy wires either flat or round. Generally speaking, flat wires are less expensive and less bulky, making it easier to maneuver throughout your van, and that's what I decided to use for my install. Now, for the more complex side of choosing a wire, you need to consider your wire's thickness. This is also referred to as gauge, denoted as AWG, spelled A-W-G. The wire gauge is a number. For example, there's 12 gauge wire, 14 gauge wire, and 16 gauge wire. Now the confusing part is, the smaller the gauge number, the thicker the wire is, and vice versa. The bigger the gauge number, the thinner the wire is. For example, 8 gauge wire is thicker than 14 gauge wire, and 6 gauge wire is thicker than 22 gauge wire. Now, to make it even more confusing, once you get down to 1 gauge wire and start going backwards, the wire gauges turn into 1/0, 2/0, 3/0, and so forth, which is denoted by a / followed by a 0. And just for reference, aught is spelled A-U-G-H-T, just so you know what the heck I'm saying. These gauges begin growing in wire thickness. For example, 4/0 is thicker than 1/0, and 1/0 is thicker than, say, 8 gauge. Furthermore, the gauge number might be followed by another number. For example, 12/2 or 10/3. The second number is referring to the number of wires in that coil. So 12/2 wire is 12 gauge wire with 2 strands. This is also known as duplex wire. The 10/3 wire means it is 10 gauge wire with 3 wires. This is also known as triplex wire. Now you can buy wires with just 1 strand of wire, not 2 or 3 like the duplex and triplex. For example, for my puck light install, I did do that. I got a red wire and a black wire just because it's going to be easier to make those connections when it comes time. So why does choosing the right gauge wire matter? Plain and simple, the answer is safety and performance. Imagine you have a current running through a thick wire with ease. Now take that same current and run it through a thinner wire. You might notice that the wire can't handle that big of a current, which can create hot wires that could start a fire or trip a breaker or burn a fuse. To choose the proper gauge wire for all of your wire runs, you should be referring to your appliance manuals and manufacturer recommendations. However, in the instance that no direction is provided, which usually there isn't, you will have to do some additional legwork on your own in finding out what gauge to use. So you will need to find out the current and amps that needed to run through the wire to power your load, and the round trip wire length needed from your distribution panel to your load. So some additional pre-planning is involved. To determine the current needed to power your load, again, check the manuals for the current listed in amps. Make sure that you're referring to the max amps, which takes into account any additional spike in the amps during startup of the unit. If the amps aren't listed, you will have to do your own math with the information provided. So to find amps, take the watts of the unit and divide it by the voltage of the unit. Now, to get an accurate measurement of the wire length needed for each individual connection, you need to know the placement of your appliances, outlets, lights, light switches, distribution panel. The ideal location of the distribution panel would be in the middle of the van. That way all of your wire runs will be shorter in length, and you can potentially use thinner gauge wire, which would mean less weight in your van and less money spent. Once you have the location of everything, measure the round trip length of wire needed for each individual connection. When I say round trip, I mean the distance from the distribution panel to the item and back. For any appliances or outlets with a switch, you will need to take into account the wire run from the distribution panel to the switch, and then from the switch to the outlet or appliance. For example, I'm using a switch for my 12-volt water pump and an outlet that will have my 120-volt Bosch water heater plugged into it. That way the loads won't be running continuously and draining my batteries, and when I do want to use the water pump or water heater, I just flip that switch and then I can go ahead and use it. In regards to the outlets, you can have multiple outlets on the same circuit, meaning each outlet doesn't have to have its own wire. So measure the distance from the distribution panel to outlet 1, then from outlet 1 to outlet 2, and so forth. For planning purposes and to get a better wire length estimation, I taped out the wire path for all my connections as seen here. Then, I used a string that I marked every foot with a piece of tape to run it along my planned wire path in the van. For a buffer, I added 2 feet to each wire run for additional wiggle room in my calculations. Once you have the amps for the load and the round-trip wire length needed, use the chart from ABYC or various online calculators that I will link below to determine which gauge wire you need for each individual connection. In your calculations, you'll be asked to include a voltage drop percentage, which is referring to the wire's resistance. It takes into account the change of voltage from the power source to the load as current travels through the wire. Voltage pushes the amps through the resistance of wire. So if too many volts are lost along the way, there won't be enough current to reach your load. The thicker wire has less resistance, whereas thinner wire has more resistance that can occur. Generally, non-critical circuits need to calculate a 10% voltage drop, and critical circuits need a 3% voltage drop. I'd recommend using a 3% voltage drop for all of your calculations just to keep it simple and to be on the safe side. Like I mentioned, you can use this ABYC chart as seen here, but after a while I started going cross-eyed trying to use it. So I used the calculators created by Far Out Ride and Explorist.life. Just plug in the numbers and go. Super simple and a lot quicker. After all of that pre-planning, I have decided to use 10-2, 12-2, and 14-2 gauge wire for all of my DC connections, and 10-3 wire for my AC connections. Now 10-3 is probably overkill, 12-3 would have probably been fine, but this gives me a better peace of mind. Now I will remind you that your calculations when you took the wire length is your round trip length, so be sure to divide that by 2 before you order your wire so you're not ordering double of what you need. Okay, with all of that out of the way, here comes the easiest part, which is the actual install of all of your wires. I will be running all of my wires behind my furring strips, in front of my insulation, and in the various holes already built into my van. Now you might also see individuals who go ahead and drill new holes into the metal of the van to make a more convenient path for their wires. And although this is fine, personally I won't be doing it because every time you drill into the metal of your van, you're creating these small metal shavings that are very hard to clean up, and if they aren't properly cleaned up, then they can cause rust down the road. So if you do decide to go this route, I would recommend holding a vacuum up next to the metal when you're drilling into it so it can catch as many of those shavings as possible, and then go ahead and apply Rust-Oleum Stop Rust Clean Metal Primer and Rust-Oleum Stop Rust Protective Enamel to that new cut that you just made so you can clean up those edges and prevent rusting down the road. Before running any of my wires, I did purchase these rubber grommets that I will be installing around the openings in the metal ribs that my wires will be running through. These are to help protect my wires from the sharp edges of the metal so that they don't wear and tear. So a rubber grommet is a donut shaped rubber piece with a split down the middle, which is where the metal piece of the van will rest in. So I was originally taking the rubber grommet and cutting it so that I could open it up and conform it to the openings of the ribs, because the openings in the van are oval shaped and not circle shaped. So I was doing that, but as you can see, the grommet wanted to fold back into its original shape. So I was struggling with this. I tried using electrical tape to hold it in place, and it wasn't working with that either. But I tried one last thing. I took a full circle rubber grommet, filled half of the oval with one, and filled the other half of the circle another rubber grommet. Now it does make for quite a tight squeeze right here. I have a lot of wires to run through these openings, so we'll see if it's actually going to work in the end, but that's what I've decided to do. Another point I wanted to make is that I'm only adding the rubber grommets to the bottom of this upper rib because that metal is thin enough and flat enough for the grommets to be added to. But everywhere else, like on the tops of these ribs, you can see that the edge of these openings are lipped over and folded over, so the rubber grommets actually don't fit on theirs. And actually on the bottom side too, it's also lipped over. So those are places I'm going to be using split loom to protect my wires when they run up through that rib. Now you're ready to start pre-wiring. I would recommend starting with 1 gauge wire first before moving on to another gauge wire so you can stay nice and organized. Around this rib. So I put a zip tie up into one of the openings and angled it to come out the side of the rib because there are gaps in it. And then I just hooked the zip tie just a little bit, didn't tighten it all the way so I can run wires through it. This way it helps to, you know, keep wires out of the way and stay nice and organized. So, and I am finding that it's a tight fit, at least for these 10-3 wires, to run them directly down into the rubber grommet in the openings. So I've actually been taking the rubber grommet out each time, and then I'm just going to run the wire down into the hole, and then once it comes out, I'm gonna add that rubber grommet back to the end, slide the rubber grommet back on it, feed it all the way back to that opening, and then I re-apply the rubber grommet in the opening. And then right away, as soon as I'm done making the run, I stop and I take this painter's tape and I write down exactly what this wire is for, because as you can see very quickly, the van will start to fill up with wires, and if you aren't labeling them, you're not gonna know what they go for. So be very detailed and descriptive. If it's on the driver's side, if it's on the passenger side, if it's for an outlet, if it has to attach to a switch, anything like that, just be as descriptive as you can and tape it onto this wire. And then you're going to go to the other end of your wire, which should still be on the coil, and after you cut it, you're also going to want to add the same exact label on this side, especially there, because that end is going to be going into my distribution panel. And when I'm wiring my distribution panel, if I have 24 wires sitting there and I don't know what either of them is for, it's going to make that a lot more challenging. Now, before I go ahead and cut this wire run and add a label to it, I wanted to make another point here that you need to leave additional wire on both ends of your wire run for every single wire run that you do, just to have that added wiggle room in case you need to adjust it throughout your build, or in case there is something that gets in the way that you didn't think about, that you need to change your wire path. It's always better to have extra wire and not need it than to need that extra wire and not have it. So personally, I am leaving an additional 2 feet on both ends of all of my wire runs just for that added protection, so that I don't have to worry about an issue down the road. So I would recommend you doing the same as well. Alrighty, my 10-3 wiring is all done, so I'm moving on to my 10-2 wires. And then after you're done pre-wiring everything, this is all that I have left over. So I would recommend running some extra runs just to have in case you want to add anything to your build along the way of building it out, or after you've been living in it for some time, you might want a different appliance, or you might want to add another outlet. So run these now so that you don't have to worry about it down the road, because once your walls are up, your ceilings are up, it's going to be very difficult to run wire and to wire something new. So just having those extra wires already ran will save you time in the future. So I'm going to be storing extra coils right there on that center beam, as well as this center beam and things like that. So use up that extra wire. Don't let it go to waste, and it's better to be safe than sorry. So just have it in your van for any future cases that you might need it.
Now that all of my wires are ran, I'm going to do some wire management. So I'm going through and applying this 3/4 inch split loom to my wires that are running through ribs where I couldn't put grommets, and for long runs as well, just to protect my wires again from the metal of the van, to protect it from when I'm screwing stuff to the wall, making sure I don't hit the wires on accident. So this is really easy to use. You just open it up, feed the wires inside of it, and then put electrical tape around it to hold it closed. So I'm doing that on all my wires, and then I'm also using zip ties just to hold stuff together. And again, wire management, which is really important during electrical, so you're making sure that you're doing everything safely. This split loom is so easy to work with. It's so easy to open up, run wires in, and then when I'm taping it up, I like pinch one side underneath the other just to make it tighter so that it holds the wires nice and snug and it can fit through all the holes and everything. But super easy to work with, especially compared to conduit, which is another option, which is like a solid tubing that you'd have to like run your wires through before, and it's not as flexible and whatnot. So I would definitely recommend split loom over conduit. And you can get it like this hard surface kind, or you can also get like a mesh material. So totally up to whatever your preference is, but split loom is amazing. So I went ahead and ran all of my wires. I left extra length on all the ends. I labeled both ends so that I know what the wire run was for. I applied the rubber grommets to the bottom side of that upper rib for protection on the wire. I also added split loom with electrical tape to help protect the wires in other locations. And I finished off by zip tying all the ends of my wire runs and coils just so it's nice and neat and organized. So that is it for my pre-wiring video. I hope you found this helpful and giving you the confidence and knowledge to do your own pre-wiring. Be sure to subscribe and tune into my next video. Like I said, I will be doing an in-depth install of my entire electrical system, from batteries to my inverter to my solar panels to my distribution panels and so forth. Until then, thank you for watching, and I'll see you next time. Bye for now.